Hello everyone, we're going to continue finishing the fourth question and the final question for Mr. Omar's quiz. And for the fourth question, we're going to break down like a full-on IB kinematics topic. And this question is a good example for like a type of question that could come up in your IB exam, and I'm going to explain like what's going on, why each step matters, and how derivatives and integrals connect everything in this kinematics question. And let's get into explaining. In kinematics in physics and math, it is the study of motion, and there are three key quantities in kinematics. There is displacement, which has a symbol of S, velocity, which has a symbol of V, and acceleration with a symbol of A. So, and how are these related in kinematics? Displacement describes position. Velocity and its derivative is ds and dt, and t is equal to the time. A is equal to dv dt or d squared s dt squared, and we're going to use these in the question above, but just note that these are important into solving any type of question for kinematics. And there is an important tip, okay? Taking a derivative moves us downwards from displacement to velocity and from velocity to acceleration. So if I'm moving down from displacement to velocity or velocity to acceleration, we're going to take its derivative. But if we're going from acceleration to velocity and velocity to displacement, we're going to take its integral. So this is actually another important tip that you should keep in mind when answering a kinematic question. Also, there is such thing called the SHM, which is a simple harmonic motion. This is when an object moves back and forth in a smooth, repetitive way. Displacement is often written as sine or cosine. It swings between a maximum and a minimum back and forth through the fixed point, like the center. Now, answering the question that is given to us. The displacement S of an oscillating body from a fixed point O in a straight line is given by S equal to sine t over 4. Now focus on this because it is our given. Anything that is given to us, it is important to fill out any question. So looking at A, it's asking us find expressions for velocity and acceleration in terms of t. So A, we want velocity, which in terms of t, which is ds dt, and acceleration, which is dv dt. We'll differentiate once for velocity and then again for acceleration. So step 1 for question A is finding velocity. To find velocity, we use the chain rule. ds dt, which is d is equal to dt sine t over 4. The derivative of sine u is cos u. So the derivative of sine u is cos u. Then we multiply by derivative of inside, which is t over 4, which will equal to 1 over 4. So v t is equal to 1 over 4 cos t over 4. Step 2, we find acceleration, and we do the same thing here. We differentiate again is equal to d dt 1 over 4 cos t over 4. The derivative of cos u is sine, and multiply by chain rule again 1 over 4, which is 1 over 16. So at is equal to 1 4 times negative sine u t over 4 times 1 over 4, which is negative 1 over 16 sine t over 4. So this is our final answer for A. So starting B, which asks us find the maximum displacement. What's the biggest value sine can take? You should know that sine is always between -1 and +1. So the maximum displacement, it has to be 1. To answer C, find the times it passes the fixed point O. What is the fixed point? We have to understand what the fixed point is. The fixed point is when the object passes the center of motion, which means when an object passes the center of motion, the displacement is 0. So in order to solve this, t over 4, 0, which is t over 4, this, according to the graphs, can either equal to pi, 2 pi, 3 pi, and t can equal to 4 pi, 8 pi, or 12 pi. And we take the first two, which is 4 pi and 8 pi. To solve D, find the two values of the velocity at these times found in question C. From earlier, V t is equal to 1 for cos t minus 4. Now plugging in the two values, which is t is equal to 4 pi and 8 equal to 8 pi, at t equal to 4 pi, V is equal to 1 over 4 cos 4 pi over 4, which will equal to 1 over 4 cos pi equals to 1 over 4 negative 1, which will equal to 1 over 4. At t equal to 8 pi, V is equal to 1 over 4 cos 2 pi, which will equal to 1 over 4, 1, which will give us 1 over 4. So at 4 pi, it's equal to negative 1 over 4, and at 8 pi, it is 1 over 4. Find the times when the body changes direction. So what does this mean? When the body changes direction. When the velocity is equal to 0, that's when it stops and turns around. So what this means is with the velocity that we have, that we know of, which is this, we got at A, we just make it equal to 0. One over 4 cos t over 4 is equal to 0, which is cos t over 4 is equal to 0, and cos at 0 is equal to 2 pi, 3 pi, and t over 4, which is equal to pi over 2, 3 pi over 2, and that will equal 2 pi and 6 pi. For the final question, it asks us to find the two values of the acceleration at these times found in E. So just like what we did in C and D, we do the same thing for acceleration. So from before, we know that acceleration is equal to negative 16 sine t over 4. So at t, 2 pi, A is equal to negative 1 over 16 sine 2 pi 4 is equal to negative 1 over 16 sine pi over 2, which is negative 1 over 16, 1. That will give us negative 16 at pi over 2. Pi over at t is equal to 6 pi. A is equal to negative 1 over 16 6 pi over 4 negative 1 over 16 sine 3 pi over 2, which is negative 1 over 16. It's 1 to give us 1 over 16. So a final recap at everything we've done. In question B, the maximum displacement is 1. At question C, which we've done here, we found the two values, 4 pi and 8 pi. At D, the velocities are negative 1 over 4 and 1 over 4. The changes in direction at T is equal to 2 pi and 6 pi. And for the acceleration, it is negative 1 over 16 and 1 over 16. And that's it. We went from displacement all the way down to acceleration using these tips. And these tips, you must know them because they're very important. And remember, derivatives takes you down, integral takes you up. So thanks for watching, and I hope you do good in your exams.